packages in R. We are going to discuss how to install package, how to load them, and other features related to packages in R. So what are packages? Packages are the collection of R functions or compiled codes in a well-defined formats. A location where all the packages are stored is called a library. Currently, there are more than 15,000 and 1,500 packages available on CRAN, that is the Comprehensive R Archive Network. How to install packages in R? So let's discuss how to install package, a single package or a multiple packages. So there are two ways to install package. First, you can do it through command, and secondly using the graphic interface. So let's go to R and let's see how to install them. So whenever we are writing a code for installing package, the code is install.packages, and within brackets and inverted commas, you are going to write the package name. For example, I want to install the package called dplyr. It is a package that is used for data manipulation. If I execute this command, so you can see a red button here. It shows that the command is loading as of now. So as you can see, it is loading the package, and you need a good internet speed for that. You can also use your mobile data for the same. The other way you can install this package is there is a tab here, package. You can click that and there is an option install. A window will open up and you can write the package name here. So it is dplyr. So you can see there are multiple options coming here, and we want the first one, so we can select it and install. For now, I have already installed it through my command, so I am not installing it again. Whenever we are going to install a package, we do not have to install it again. In every session, whenever you are starting to write a code, you will have to load that code. You have to load that package in that session. So let's see how to load a package. Before that, let's install multiple packages. How can we install multiple packages? The command that I am using for that is install.packages. Inside bracket, I am giving a combination, like I have already installed dplyr, so I am removing it from here, and I want to install plotly and reader, so I'm going to execute it. So you can see the packages are installing in the background. Similarly, you could have also installed it through the GUI using RStudio in packages, clicking on install and one by one installing both of the packages. Now let's see how can we load a package whenever we are starting a new session. So to use the codes or functions that are built in that package, we have to load that into our session. It means before using it, we should have those package functions in our system. So once installed, you do not have to install it again. You just have to write a command library dplyr, or whatever your package name is, you can write it inside the brackets. So library is the command to load the package. Let's run this command. So what it is saying is the following objects are masked from the package base. So these are the within the package there are multiple functions, multiple objects which are loaded into our session right now. You can also load multiple packages at one time. For example, what I have done is I have created a vector here with name my packages. Within the bracket, I have combined name of three of the packages, that is dplyr, ggplot and lubricate. So what I want is in my session, I want to use functions from these packages. So I am loading these packages in my session. So I have created a vector. Now using library function within the brackets, I have given the name of my vector which is having different packages in that. So let's run this command. So what you see is we have created a vector here, and if you run this command, so when you want to install multiple packages once, so there is a package called pacman. So you can install it through packages here. Type the name of the package like pacman and install. I already have this package in my system, so I am not installing it. After that, what you can do is you can write the name of the package here, pacman. What does 2 do here is it will take the function from this package, that is pload. That is, we want to load these packages from the package pacman, and within the bracket you can write the name of the packages that you want to load in that session. So let's run this command. So what we have done is we have loaded the packages dplyr, tidYR and lubricate. Now if you want to check what all packages are loaded in your session, what is the command for that? It is search and bracket. So you can see in my current session the packages that are loaded, that are lubricate, data.table, tidyverse, deployer, RStudio. These are the base packages, and the packages that I wanted were deployer, tidyver and lubricate, which are already loaded with this command. Next is how to detach a package. If you do not want to load that package further, like you're changing your commands, you're changing your analysis, what the command is, you can type detach, and within bracket in inverse commas you can type the name of the package and unload equal to true. So what you are doing is you are unloading this package from your current session. So I am executing this command. So when you want to detach a package from your session, like if you do not want any further function from that, so the command is detach. We are detaching the package and unloading it. So the command is detach. Within the bracket, package name is dplyr, that is the package that we want to detach, and unload equal to true. So let's run this command. So how do you know that the package is not in our session now? So there is the command that I told you, that is search. So it shows the current packages in our session. So we do not find dplyr here. Also what we can do to attach or detach the packages, go to packages. There is list of all the packages that are already installed in your system. So you can search the package here, like in search I'll write dplyr, and you can see there is a checkbox here. So if I take that package, so you can see it is loaded in my session now directly. And if you want to detach it, what you can do is just remove the tick mark and it will be detached. Similarly, you can do it for multiple packages in one go. Like if I want this package, this package, this package, so I can tick them together and it will be loaded in my session. Similarly, I can detach them. You can see the command itself, it is running in the system. So next is how to remove the installed package. So you have installed the package, there is some error or it is not running. So what you can do is you can type the command remove.packages and within the bracket and inverted commas the name of the package. So what it will do is it will remove the package from the library installed in your system. It will be removed from the package area also. If you want to check this, I can run this command and you can see it is showing removing package from my library, the folder where all the library is stored, and you can check the list here. dplyr has been removed from the list. Next step is updating the existing installed packages. So whenever you want to install the existing package, the command is update.packages. What it will do is it will automatically update all the installed packages in your system. And if you want only specific packages to be updated, so the command for that is update.package. Within the brackets you can mention old package, old pkgs, that is packages, equal to within the concatenation formula I have given two name of the two packages that I want to update. So you can run this command and only dplyr and lubricate will be updated. Rest all will not be updated. Subsetting data in R. Subsetting is used to select or exclude variable and observations from our data. It makes the data more precise and as per the need for our analysis. We use three methods to subset the data in R. So first is square bracket notations, second is subset function, and third is which function along with the bracket notations. So let's start with bracket notations first. So bracket notations helps in sorting our variables and observations and extract only those which are in need. For subsetting the data, we use square bracket notations as you can see in the example, and it follows RC principle, that is row into column principle, where X consists the rows from the data and Y will consist all the columns of the data. Now let's go to R and create command. So first I'm creating a data frame matrix with a variable name df. Using matrix command, values from 1 to 12 and rows will be 4 in this matrix. So let's execute this command and check the values of df. So you can see there are 4 rows and 3 columns in this matrix. Now we will extract the data from this data frame. First we are subsetting the first row. So as we already know that inside the bracket notation we follow R into C principle. So the first variable number before comma it will be the rows and after the comma it will be columns. So as I am extracting only the first row, so I have mentioned 1 here, and before the square bracket it is the name of the variable in which matrix has been saved. So let's execute this command. So you can see the first row from our matrix has been returned as an output 159. So there were 3 columns, so there are 3 values because we kept the column part empty, which means we want all the columns of that matrix. Next, similarly, we can extract column 3. For that, we will mention 3 in the column side and R will be empty because we need all the rows, value of all the rows, but only in third column. So let's execute this command. So you can see these are the values of the rows mentioned in the third column. This is the third column and all the rows, and values are 9, 10, 11, 12. Next, similarly, if we want to extract the values of row 1 to 3rd and column 2. So what we will do is we will mention 1 to 3 in R part and 2 in the column part. As you can see here, 1 to 3 will return the rows from 1 to till 3rd, and the rows will be values will be only of column number 2. Let's execute this command and check the values. So you can see in second row column the values are 5, 6, 7, 8 in the 4 rows. So we need only 1, 2, 3. So 3 values has been returned. Next we are subsetting a vector. So for that we will create a vector first and I'll save those values in X variable. Let's execute this command and check the values of X. So you can see there are 4 values in this vector. Now we will extract the elements from this vector. So if I want to extract third and first element, first I'll mention the name of the vector, then the values that we want to subset inside the square bracket notation. So if I want 2 elements, one is for that I am using the combine command here or the concatenation command and mentioning 3 and 1. So here it is not R and C because it is a vector. These are the element numbers. Let's execute this command and you can see the third and first. So first it is mentioning the third value, that is 3.3, then it is the first value 2.1. So it follows the order in which you are mentioning it in combine command within the subset. Next we are omitting elements, and that we are mentioning the position. We will specify the position inside the subset notation. Those notation and those elements will be omitted from our result, and except those all the vector values will be in our output. So to omit the elements, what we are doing is we are putting a minus sign before the combination command. Now let's execute this command and you can see except the third and first element, others are showing in our output. 4.2 and 5.4 is the result of our subset. Now logical vectors select an element where the corresponding logical value is true. Now, as we know, there are 4 values in our vector. What we will be doing is we will be subsetting the values corresponding to the logical values mentioned in the subset. So we are using true and false for that. So position wise, we mentioned true, true, false, false. So there are 4 values. So 4 logical values are mentioned inside the square bracket notation. So where I have mentioned true, those value will return, and else other values will be omitted. So you can see the output, only first and second element has been printed in our output. Similarly, you can give a condition inside your square bracket notation, if the result that you want according to that. So here I am saying all the values that are greater than 3 in the vector x, I want those values in my subset. So all these values are greater than 3, so they have been printed. You can always save these result in a variable so that you can use that variable for further analysis. So if you do not mention any of the values or any condition inside the square bracket notation, it will return the whole matrix or the vector as it is. Now, if your vector has a name with it, if your vector is named, so I am setting names for my vector. My vector was x, and I am saving those new vector inside y variable. So set name command helps us to name the vector. So I am giving the vector name and comma letters from 1 to 4. So it will be named as ABCD for the every element. Now we are extracting column names using the column names. As you can see, I am using y variable now, in which my new vector is saved, and within brackets I am taking the names, column names, to extract the values. So you can see, as I have mentioned, I want D, C and A's value. So similarly my result is D, C, A value, that is 5.4, 3.3 and 2.1. So you can again, I am taking a matrix here with values 1 to 9 and 3 rows 3 columns. If you want to check the values, and I'm giving the column names to it as ABC. So this is the output of my matrix. Now we will extract first row and second row from the list, from our matrix. To extract first and second row, I am using colon here, 1 to 2 in R part of this subset. So again, as it is a matrix, we are using R into C principle here. So only the first and second row has been printed here. Similarly, you can extract an element from a particular position. So if I want a value from third row and third column, this is my whole matrix. So third row is this one and third column is C column. So I should return, I should get an output of 9 here. So let's execute this command. So I want third row, element from third row and third column from dataset A. So you can see it is 9. So I am excluding second column and second from row from my data set. For that I am using a minus sign before the number, row number or row column. So you can see the second row and second column has been removed from our data set. Now if you want to subset from a data frame, first you need a data frame. So this is the data frame that I have created. There are x variable with 1 to 3 values, y with 3 to 1, and z with letters A, B, C. Now I want to extract data in x. If I am saying df$x, so it will take the values from x vector, x column, which is equal to 2. So in whichever row the value is equal to 2, that row will be printed. So you can see the second row, it is 2 to b, it has been printed with this command. Now let's go to next method, that is the subset command. For subset command, it takes the input as vector, matrix, data frame. It can be used for any of the data structure, and it will subset and return the values from in the form of vector, matrix or data frame following a particular condition that will be mentioned in our formula. So the function that we use for subset is subset within bracket x. X is the object or the matrix data frame that you are giving as an input, that is your data set. Next is the subset. So subset, it is the function or the command or a condition that you give in order to subset your data. And select here, select is the expression indicating which columns of the data frame you want to select data from. So let's go to R and create the conditions. So first I'm taking set.seed. So what does set.seed do? Like you can take any of the numbers inside the bracket. It can be 3, 4, 5, it can be 1000, 1, 2, 3, anything. So set.seed fixes the number whenever you are taking a sample number or a random number to create a data set. So it fixes your number. It will not change values whenever you will run that command. So set.seed. Now I'm creating a matrix. So I'm using round command here. Round command what and giving the decimal point as 2. So the numbers that will be returned, it will have values till 2 decimal points. Within the matrix command, I am using rnorm condition. So rnorm is the random normal distribution. For that I am using 30 values with us standard random numbers from for 30 values with the mean of 1. You can always use question mark before the function in order to get help from R regarding that function. So I am using R norm within matrix. So I have taken the value of numbers in that matrix that I want, that are 30 values, and columns I want 5 columns here, rounded till 2 decimal values. And I'm creating one more column, and that is Y, in which I have used sequence command. So I want 1 with a sequence of 5, difference of 5. So let's execute it. Now I'm combining both the columns, as you can see. So these are the X part and Y column that we created after the X1. So converting X into a data frame. So to convert it, we just use the command data.frame and give the variable name. So you can see all the columns has been named as V1, V2, V3, V4. It get the name default by default because we are not having any of the headings here. Now let's use subset function to subset the data from this data frame. So we want subsetting rows using the so we are subsetting the rows here. First, inside the function we give the name of the data frame. So here it is x.df, and then giving our condition. So all in this y column, all the values greater than 2, we want to return all the rows having y equal to 2. So you can see we have 4, 5, 6 row here. Now these are the rows that have been printed because the value of 2 here is greater and the value of y here is greater than 2. Similarly, so if you are able to understand the subset function, first you are giving the name of the data frame in which you want to subset the data. After that, you are giving the condition on which your subset will be created. Again, if you want to give multiple conditions using AND operator here, so the data frame name, after that condition was y greater than 2 and v1, that is vector 1, greater than 0.2 value. So let's execute this command. And you can see 2 rows has been returned where in v1 the value is greater than 0.2 and in y column the value is greater than 2. Now if you want to subset using both rows and columns, I am giving the same condition here. X the data frame name, then y greater than 2 and y2 v2, that is vector 2 greater than 0.4. Then select. Now here select, what does it do is it will use only vector 1 and vector 4 to return the subset values. So you can see only one row has been returned in column v1 and v4 according to our condition given here. Next is the which command. So which command helps us to return the position of the value whichever specified in the bracket. Let's go to R and explain further how which command will be used. So let's check the letters. So let's check the letters available to us in R. So they are obviously A to Z. There are 26 alphabets in our English alphabets. So we are using which command to get the position number of the Z alphabet here inside. So using which command within the brackets, I am saying in the letters exactly the specific name that I am giving here is Z. So I want the position in which Z is saved. Let's execute this command, and you can see it is the 26th number, the Z variable in our English alphabets. Similarly, if you want for S, so it is the 19th alphabet. Now, if you are using any data set, data frame, any data set, like we have a inbuilt data set women here. So I want the position of the row. I'm using the data frame women here, in which I want the value, the specific position of the value 66, where the women's height is equal to 66. Let's execute this command. So in position 9, that is the row 9, the value of women's height is equal to 66. If you want to check this data, let's check the women data set, and you can see in row 9 it is 66 value. So if you understand which command, what does it do, it returns the position of the value or condition you are giving inside the bracket. Similarly, if you want the height, a number of the position where height of the women is greater than or equal to 70, so the values are 13, 14 and 15 position. You can see in the column in the data set also the values are 13, 14 and 15, where the height of the women is greater than or equal to 70. So let's use this function to subset the vector. Now I'm creating a vector here. I have taken different values. Now if I take condition as j greater than 6, let's see what is the result. So you can see for each and every value in this vector, it has returned false or true. So wherever the value is greater than 6, it will return true for that value. Now if I use which condition with that, it will return only the positions where the value is true or the value is greater than 6. Now if you want to subset this data and I want to save it in a variable, let's take a as a variable, and I want to create a subset out of this vector using which condition. So I am taking the first the vector name here, subsetting using square bracket notations, and giving the command using which function. So all those values in the vector j which are greater than 6 should be saved in variable a. Let's print the command. So you can see if only which condition was used, the positions of that values are were the output. But if you use a square bracket notations with that, it will return the values of that from that vector. Similarly, I have taken it for letters only. It is if you want small case letters, you can always type letters in small case. It will return you all the alphabets in small case, and if you want them in capital case, so you can take you can print the uppercase letters. Now let's take one more example. I am creating a vector here for marks. If I use which function, it will return the position of the marks where they are greater than 30. So you can see the third and fourth position values are greater than 30, 40 and 60. Now if I subsetted those values using square bracket notation, this should return the values. So you can see the third and fourth position, the values of that position were 40 and 60. So using square bracket notations along with which command, it helps us to subset the data from the data frame. Similarly, there is one more command that is the grep command. So you can always question mark it. So it will group your data and will return the output. So it follows a pattern matching to your requirement and will return you the data. Now I am creating a vector here with character form data type. So I have taken names here: Jack, Jill, Tom, Jerry, Bugs Bunny. Now I am using grep command and saying that all the values in all these vector values. So grep command is used. First we give the subset or the value that we want to check in this data frame in this vector, then the name of the vector. After that, ignore case is true. So if there is any in any case where there is false value or there is no matching value, so it will be given as true. Let's execute this command. So it has returned me with two positions, that is fifth and sixth. In fifth and sixth, we can see the subset values that we have given, they are matching in that case. So it has returned me those positions. Now if I want to subset those data, again you can use square bracket notation for that from the vector name. So vector name square bracket, within the bracket same command that we used to get the position. So you can see it has returned you the names of those uh, characters in which BU is common. Last example that I'm using is of empty cars. So empty cars, as we all know, it has 32 rows and 11 columns. If I use which command here, so what does it do is, it has returned me all the positions, positions in MPG values where they are greater than 25. These are the position numbers. Now, if I want to subset this data frame, again I'll use square bracket notations, and it will return me all the rows of that position number where the value is greater than 25, and this should be in the R part, that is the row part, and column part will be empty because we want all the columns to be returned. So let's sum up the subsetting of the data. We are using three methods here. First is the subset function, wherein I have taken the example of a data frame x.df. So we are subsetting the data frame x.df based on the condition where y value is greater than 2. Next we use was square notations. It is very important and mostly used subsetting command that we generally use is square bracket notations. So it always follow R into C principle. You should remember that. If you want to subset the data, you should know which is the R row part and which is the column part. First, before column it is rows, and after that it is column. As you can see in the example also, you give the name of the data set, that is X. Within the square brackets, you can mention the rows and columns here that you want to include or exclude. If you want to exclude it, put a minus sign before the value, it will exclude that value. The last we used is which command. In which command, it returns the position of the value when it satisfies the specified condition. And if you want to subset that position number, you can always use a square bracket notation with that using the dataset name. So it will return you the values of that position. Data management in R. Once we have access to the data, we need to manage it and build it into a data that is useful for analysis. In data management, we will cover the topics that will help us to reshape our data according to our requirements and to analyze it in a better way. So let's start with renaming the variables in R. The first method to rename is using setName command. It is used by using the package data.table. So the input for this command is either table or data frame. You should have an old name vector and a new name vector that you want for your columns to be renamed. Next command that we use is names command. In names command, we will use it along with the square brackets notation. So in this, we use index number, as you can see mentioned here is 1, to identify the column number of which we want to change the name. Next, we can use the again name data along with square notations, but particularly specifying the name of the column that we want to change. Let's go to R and practice some commands. So the package that I'm using here is data.table. I have already loaded this command. You can see in my packages, I already have this data. So let's load this by using the command library. Now the data has been masked to my session. Now what the formula that we will be using for set names is set names. Within bracket, it will be the data frame name. Then there will be vector with old names, then the vector with the new names. So I am creating a data table here with variable TMP using the formula that is data.table. So I'm converting these value into a table wherein I'm saving A with 1 value, B with 2 value, and D with 3 value. Let's execute this command and let's check the value of TMP. So you can see I have created three columns here with A column, B column, and D column with have 1, 2, and 3 values. Now we have the name of all the old columns, that is ABC. So it's ABD here. Now I'm creating a new vector with new names. You can change the name of the vectors whichever you like. So I'll be updating it with CENF and I'll execute this command. So I have created this vector. Now I'm using the command set names. Within bracket, I'm mentioning first the variable in which my table is saved. Next, the old vector, vector with old names. Then new one and skip absent. So skip absent means if there is any variable or any column with where the values are not present, so it will skip those values. Let's execute this command. Okay, so I have not executed old here. So I have created this vector, and now let's execute this command and check the value of TM field. So you can see we have changed the name of headings here. The column earlier they were ABD, now they are CEF. The second method that we can use is the names command. So I'm using the dataset empty cars, which is the inbuilt dataset. Let's check the names of this empty cars. So there are MPG, cylinder, displacement, and others. I am saving these variables in a vector I. So what we will be doing is we will be changing the name of MPG to uppercase, that is capital MPG. How we will do that is using names command, NAMES. Within bracket, I am mentioning the name of data frame that I am having, that is I, and square brackets to subset. Square brackets are used to subset the data. So I am mentioning 1 here, that means the column 1, that is MPG, and the operator that I am using is the leftward side operator. What it does is it will save the value of MPG, capital MPG, in this 1, that is first value, that is index number 1, first column. Let's execute this command and check the names again. So you can see the MPG that was earlier in lowercase, it has been updated into the uppercase MPG. Similarly, you can do by specifying a particular package, particular name of the column. Earlier we were mentioning here is the index number. Now I am mentioning particular column name. So for that I am using double equal to. So the command that I have used here is names command. Within brackets the name of the data frame. Then inside the subset using square bracket notation, I'm again saying name I. So I'm saying all the names in this I data frame in which there is a particular column, that is CYL in small case, I want to update into capital case. I have executed the command. Now let's check the names. So you can see the name has been updated to capital or uppercase CYL. Let's move ahead with the next data management thing. So we are adding or deleting rows or columns to our data frame. So first we will be adding and removing rows. The first method to do that is by using rbind. So rbind helps us to add a row to our data set. How can we do that? Let's go to R and do that. I'm creating a data frame here. The name of the data frame is df. The command that we will be using is data.frame. Within brackets, I have created two vectors, that is A and B. A with 1 and 2 values, B column with 3 and 4 values. Let's execute this command and check the value of df. So you can see there are two columns with 4 values, 1, 2, 3, 4. Now we will be adding one row to it. So how can we do that is, so I am creating a new row here, that is for 7 and 8 value using C command, that is the concatenation or the combine command. Now I'll be using rbind, that is row bind. Within bracket mentioning the name of the data frame in which we need to add that row, comma, the name of the vector with that new row. Let's execute this command. First I am creating the vector, then I'm using the command. So I'll be saving it in df itself so that it will get updated. What will happen is the rbind command will be executed on df and it will be saved in that same data frame. So you can see the value of df, it changed to 3 rows. Earlier there were only 2 rows, now there are 3 rows with new vector, that is 7, 8. Now there is one more way to add the row, that is by using square notations. Let's do it also. I am using the same data frame. Now the command that I will be using is first mentioning the name of data frame, that is df. Then I am subsetting the data. What I am doing is I am saying n rows df, that is n rows. The last row or the total rows of df, add one more row to it. Then I'll be putting a comma and blank. So I am not mentioning any column. I'll be I'm only covering the row part. So everything that I'm adding is in the row section. Then I'll be saving a vector to it, that is 5, 6. Let's execute this command and check df. So you can see we have added a fourth row to it, that is 5, 6. Now we will remove the command. So there are two ways we can remove the command. Either we can use a single row, or we can delete two rows. For deleting one row, it is very easy to remove a row from a data frame. You can just use a minus sign before the name, the number of the row, it will get removed. So I'm taking the same data set. So to show you how to remove a row, I'm using the data frame women here. It is also inbuilt data set. Let's check its dimension. So you can see there are 15 rows and 2 columns. The dataset comprises of height and weight of 15 women aged between 30 to 39. Now what we'll do is we'll delete row number 14 from that dataset. I'll be saving that dataset into test variable. So let's create test. Inside that variable, I'm taking the name of df, that is women dataset, and I'm subsetting it using square notation, and I'm showing minus sign here. So what I'm saying is delete row number 14 from this data set. Minus sign deletes that row. Let's execute this. I'm using tail command. There are two commands that help us checking the data with less number of variables, head and tail. So head gives the output with first 6 rows of that data set, and tail commands gives the last 6 variables, last 6 rows of that data set. If so, there are total 15 rows in this data set. So I'll be checking the last 6 rows with tail command. So you can see there is 13, then there is directly 15. 14 number row has been deleted from this data set. You can also check the dimension of this data set to confirm. So I'll be checking. So you can see there are only 14 rows now. Earlier there were 15 rows. Similarly, what we can do is we can delete multiple rows by using multiple numbers with the concatenation or combine command with a minus sign before it, so that we know that in women dataset we want to remove 6, 11 and 13th row from this dataset. And again I am saving it in test1 variable, and let's check the data set. So you can see, so we removed 11 and 13. So after 10 there is 12, and after that there is 14. And if you want to see if 6 is also removed, you can check the whole data set. So you can see there is 6, 11th and 13th row has been removed from the data set.
Now let's understand loops and if-else statements in R. If-else statements, there are different types of if-else statements that we can use in R. So first is if statement, in which there will be a code block that will get executed if the condition is true. The second is else statement. It gets executed when the condition is false. The third is else if statement, which specifies new condition if the first condition is not met. The fourth one is if else statement, used to check the conditions for all the elements present in a vector. Let's understand them one by one. So the first one is if statement. So if statement is executed, is used when we have to specify, when we have to evaluate a condition, if it is true or false. If the condition that we want is true, then the statements written in the curly brackets, they will execute themselves. The second one is nested if. Now, nested if works when there is a if condition, there is a condition that we want to evaluate, which is true or false. If it is true, the statement inside the curly bracket, it will get executed, and then there will be an additional if condition inside it, which again will check the condition and execute the statement that will be written along with it. So nested if contains an additional if inside the main branch. Next is else statement. Now else statement is added, like if statement was used when the total block, when the condition is true, At that time, if condition is executed. But if the condition is not true, it is false, at that time else block is used. Now else says if the first condition is not met, then execute the second statement. So this is how else will be used. The next is else if statement. Now else if statement includes multiple ifs. So first condition will be checked. If it is true, it will get executed. Another, then we will add one more if condition with else command, and again it will check the condition. If this new condition is true, if it is positive, the statements will get executed. Otherwise it will again go to the next else, which will be the false branch, in which if none of the above conditions are met, then this else command will be executed. Next is if else function. Now, if else function is a part of R programming. It's a function present in R in which we will check the condition. If it is, so it's just one statement in which first is the condition that we will give. If the condition is met, then the second part is the statement for the true. And if the condition is false, then it will be the third part of the statement, that is the false statement. So if the condition is met, it will execute the true statement. If the condition is false, it will execute the false statement. This is how else function work. Now, there are some loop function as well in R. So first loop that we know is while loop. While loop works same way as if condition. So until it says while the condition is met, we will evaluate if the condition is true or false. Then the statements, whatever written in the statement part, it will get executed. Then the second one is loop, the for loop. Now, for loop works, which says when you want same thing to be repeated many times. So, for example, all those values in this, in any vector, for this number of value, the statement will be keep repeating itself until it will reach a condition. So it is for loop. It will work until it will reach a position or a last limit that we have given for that loop. So let's go to R and understand all these functions through codes. Let's understand if else statement in R. Now, I have taken two variables here. First is X, in which I have saved a number 50, and the second one is Y, in which we have saved 80. So these are two variables that have been created. We will use it to understand if condition. So how to use if condition in R? We will say if X is greater than Y, X is less than Y. So what should happen? I will start a curly bracket, and for the statement I will write print Y is greater than X. So what should happen if this condition that we have given here, wherein X is less than Y, if it is met, it is true, it will print Y is greater than X. Let's see if it is working. So ideally it should print it because Y contains 80 and X contains 50. Let's select it also. Whenever you want to execute a if block, you have to select the whole command and then you will execute it with control enter. So you just saw the output is Y is greater than X because this condition was true. Let's try to just change this symbol. Let's make it greater than. So it says if X is greater than Y. So I have changed the condition now. Let's see if it is printing this or not. So I'll execute it again. I'll select the whole block and I'll run the command. So you see there is no output because the condition was false. So this is how if statement works. Now we have used it inside curly brackets. You can also use it without curly brackets. So how to write it? Says if X is less than y. So this is the condition that we have given. You can directly write print y is greater than. Let's see. So it works like that without curly brackets. Now the next is nested ifs. So there are three values we have taken here. X and y we already had these. We have created a new variable z with value 90 in it. Now to create nested ifs, the condition that we will give is, so if in the bracket I will say x is less than y, then what should happen? I'll open a curly bracket. There will be a statement first. So statement is, if it is true, it should print y is greater than x. Now, if this is true, this will print. Now, I will add one more condition to it, which says if z is greater than x. So I'm checking value of z. If it is greater than x, so it should print. I'm using it without curly brackets here. So I will say print. It will say x is smaller than y and z. Let's see if it is printing. So I'll select all of it and I'll just enter. So you see, both of the statements have been printed because both of them were true. Let's try to change one condition here. Let's make z is smaller than x. Now print this. So you will see only one statement has been printed, that is y is greater than x, which is this, because only this if condition was true. This condition was false, that's why it did not get printed. So this is how you can use if nested ifs. Now let's start with else statement. So again I am using the same vectors. X is 80 and y is 50. Let's execute both of them. Now we are using else statement. So it will start with if and we will add else to it. So it will work as if x is greater than y. When x will be greater than y, I will start with a curly bracket and I will print, let's say print x is greater than y. Okay, and I will add else to it. Now what is the else condition? When y will be greater than x. So at this point I want to print else. I will give a curly bracket again and I will print. I'll open a bracket and print y is greater than x. So it says if if x is greater than y, it should print x is greater than y. It's opposite. When it is false, it will print y is greater than x. So let's select everything and I'll do control enter. So which of the condition is printed? So we have x equal to 80, y equal to 50, which means x is greater than y. So this condition was true. So the first condition and the first statement got executed. Now let's change the values a little bit. Let's make x as 50 and y as 80 and I'll execute both of them and together you will execute the whole if else condition. So now this condition was false, so it came to the else part and it printed y is greater than x. So this is how you can use the else statement. Also, we can use it without curly brackets. Now, how to use it without curly brackets? So you can say if x is less than y, so what you can say, print, So we will print this. Otherwise it should, else it should print x is greater than y. Let's select the whole statement and enter. So because the second statement was true, the first statement was true, wherein x is less than y, so it printed the first part. If we change it, let's make it greater than and enter. So it printed the second part. So this is how you can use the if else statement. Next, we will learn how to use multiple else if statements. So let's suppose there are three variables, x equal to 80, y equal to 50, and z equal to 90. Now, how to use multiple else if? So it will start with if. I'll give a condition. So let's say the condition is y is less than x. I'll start a curly bracket. And what I need to print is, let's say I want to print x is greater. Now, there will be a else and if again, which says a condition. Now, the next condition I can say z is greater than y. So here I will again give a curly bracket because it's an if condition. So it should have a statement with it. So I want to print z is greater. Else, now this is the false part. If none of the condition is met, then this should happen. Now what is else? It should again start with a curly bracket and there will be a statement which will say print x we have taken, z we have taken, so y is greater. And I'll close it. Now let's try to print it. So I'll select everything and run it. So what happened? The first condition was y is less than x. So if you see, this condition has been met. Y is less than x. So it stopped here and printed x is greater. If you check here, z greater than y, which is false, therefore it didn't execute it. Same for this part also. Let's try to change this. Let's try to make it less than. Let's try to make it greater than. Now, let's see what happens. I'll select everything again and I'll run it. Now, the second condition got met, wherein our z was greater than y. That's why this second else if condition got met. Now, if I change some numbers, now we want to make all the conditions as false and print this value. So how to do it? Let's change this condition as well and try to print it. Let's see what executes. So the last part, the false part got executed. So this is how we can use multiple else if. We can even add more else if to it depending upon our requirements. Now, if we want to write it without curly brackets, how we will do that? If I'll say the first condition y greater than x, and then I'll say what I want to print. I have to print this. So I'll just copy it here. And then next condition is else if. So if z is less than y. Again, I want to print something. I want to print is z is greater. Or what should happen if nothing is met? It should print else print directly. I will say else print y is greater. And I will close the bracket and I'll execute it. Let's see. So if you just saw,
y is greater has been printed using this command. So this is how you can use else, multiple else if in a single statement without curly brackets also. Next we will understand is if else function of R. Now for that what I am doing is I am creating one vector, let's say v equal to, so I'll be using random normal distribution. So I'll say R norm, it says random normal distribution, wherein I want some numbers. So it can be any number. So I'll say 20 numbers which has mean of 0.5, let's say, and standard deviation of 0.15. So I'm taking it randomly so that it's normally distributed, and I'll press enter. And let's print this v. So if you check the numbers, it's the numbers are in long decimal points with a mean of 0.5 and standard deviation of 0.15. Total there are 20 numbers. Now what we want to do is, let's say we want to create one more vector v1, and all those numbers which are less than 0. Let's say 55, it should turn to 0, and numbers greater than 0.55 should turn to 1. Let's see how to do that. So we say if else. So I am giving both the conditions, if and else together. So first part of this statement, first part of this function is the condition. If you check here, it says test yes, no. So the test is the condition that we want. So if we are saying if v is less than or equal to 0.55, what should happen? The next thing we will provide is if this condition is met, what is the true thing should happen? So it should turn to 0. And if it is greater than 0.55, it should turn to 1. Let's see if it is working. So there is an error. Error says, so there should not be any space between less than and equal to. Let's execute it again. And I'll print these values again. So just see this value 0.599. It was bigger than 0.55, so it converted to 1. Because this condition didn't met, it was false, so it came here, it executed it and converted into 1. The second number was 0.53, which is less than 0.55, so it was true, the condition was met, and therefore true statement got executed. So this is how you can change all the numbers range using if else condition. Now, if you want to check, like if you want to compare them, you can always use cbind function. Cbind, what will it do? It will give v and v1, both the vector name, and it will combine, and you can easily compare what it turned to. Next, let's understand while loop. Now, while loop, any loop that we will work on, loops work until we have given it a condition or a fixed point until it should repeat. So let's say there is a variable wins, and I'll save 10 in it. No, instead of 10. Next, let's understand while loop. Any loop, whether it is while or for, loops work until we have given a condition, and it should be repeating itself until it meets a condition, its last point. So here, let's say there is a variable called as wins, and I'm saving a number in it 0. Let's execute it. Now, what I want to do is, I'll say while, I'll open a bracket, I will say while wins is less than 10. So this is the condition that I am providing. Until wins is less than 10, what I want to do is, I'll open a curly bracket, I will say print. So it will print something. What should it print? I'm using a function called as paste.
This paste function, whatever you will provide inside this paste, it will print that. So it will combine those things and it will print it. Inside paste, I will say count. Let's say count, and I'll put a hyphen, and then I'll put a comma, and I'll give this variable number, this variable name. Now, what will it paste? It actually will, what it will print is, it will print count, then there will be a hyphen, and the number saved in this variable. First number, it will be 0 because initially it is 0. Now, once this get executed, this statement, what should be the next statement? My wins should increase by 1. So I'll say wins equal to wins plus 1. Let's take it together, whole while block, and I'll print it. So if you see, it kept repeating until it reached the last number, until it is less than 10. So it started with 0, what was initially the value in wins. Then it printed counts with, because it added 1 to it. So the next number in this wins becomes 1, which is again less than 10. So it printed count 1. Again, it added 1 to it, which becomes 2. Now it contains 2 here, which is again less than 10. So it printed count 2, then count 3. So it will keep repeating till count 9, because after it, it will add a 1, which will become 10, and which is equal to 10. And it will stop and come out of the loop. So this is how while loop works. Now let's understand for loop. So for loop, I am creating a variable here with 5 numbers. Let's execute and print it. So these are the numbers present in this variable v. The vector, numeric vector. Now what we will do, we will create a for loop. So for what inside it, what I will say, for I in v. Now what does it mean? I in v. This I is nothing but a name for variable. It's a array index, whichever number present in this variable, in this vector. So it will check the vector, it will take the first value, let's say 1. So it will say 1 in this vector v. For that, what will it do? It will print I. So what I want to do is, for every time number is available in this v, all those numbers will be printed if this, until this condition is met. Let's execute it. So what happened? It counted it. So for 1 in v, it prints I, the value of I. The second I is 2, which is present in v. So it printed that value. So it will keep printing till the last number is met, which is 5. When we reach the last number, it came out of the loop. So this is how for loop works. Let's take one more example. Let's say there is a vector x, which contains some values. Let's say 2, 5, 3, 9, 8, 11, 6. So these are the random numbers that I have taken. Let's execute it. Let's create this vector. Now what we will do, we will create one more variable. Let's say count equal to, let's say value is 10 in it. So we'll create a loop which will contain both of, which will relate both of these. So for value in x. Now value here means all these numbers. So it will be, value will contain 2 initially, then 5, then 3. It will keep changing with the numbers in this x vector. For value in x, what should happen? Until this condition is meeting, so this loop will work until the value of value in x is checked, and for that I am giving a condition. So if value, so this value which is taken here, it is less than count. this variable. So if it and the count contains 10. So until this value which is checking in this vector, it is less than 10, what should it do? It should do count equal to count minus 1. So we are subtracting 1 from count every time by checking this loop, and it will print count. So it's a random loop that I am creating. I'll just print this as well. So I'll select all the rows for the for block and I'll execute it. So how does it work? So first number was 2. The first number was 2. The first value here, it was 2, which is less than count, which contains 10. So it is less than 10. So it reduced 1 from that count and printed it. So the first value was 9. Now this count contains 9 in it. The next loop will work. It will again work for the next number, which is 5, which is again less than count, and it will again reduce 1 from it. So it becomes 8 because it reduced 1 from it. This condition was met and 1 was reduced from the count. Let's see. The next number is 3, which is again less than count. The count contains 8 in it, which is less than 3 is less than 8. It will again reduce one number in count and will print 7. Now the next number is 9. Now count contains instead of 10, here it is now 7. You check, it's 7. The last number it contains is 7. Now the number in X is 9, which is greater than 7. So this time it will not get executed and it will directly print count, which is the same value. Same for the next two values as well, because 8 and 11 both are greater than 7. Again 6 is less than 7. So the condition is met and the statement got executed. It reduced 1 from the count and last print is 6. So this is how you can create a loop, a for loop in R. There is something in for loop which is called as break statement. Let's see how to use a break statement as well. So this is the vector we have already used, which contains 5 values in it, 1 to 5. What we will do, we will create a for loop which says I in V. It will start with a curly bracket, and inside this bracket we will give a if condition. So if I is equivalent to 3. So I have given here 2 equal to, which is says equivalent, to make it to check it. It's kind of a check operator. So it will check if I is equal to 3, it will give a break. And I will close it. And else it will print I. And else it will print I. Let's see, is it working or not? So I'll select everything. So what will happen? It will check the values. It will count the numbers in B. When it reaches 3, it will break and come out of this loop. Let's see, is it working the same way? So it checked first 2. When the first value was 1, it got printed. Second value, which is less than 3, again it is not equal to 3, so it again got printed. Now when it reaches 3, because we have given the condition, when it reaches 3, it should break and come out of the loop. So that happened, it came out of the loop. So this is how we can use if-else statements and loops in R. Missing values in R. So missing values, they are the missed values or unknown values that are present in the dataset that we are working on. In today's time, it is the most common problem or challenge for any data analyst. Now, what should we do with this missing value? Should we ignore it or treat it? We should not ignore these missing values, as removing them is the most important part of data processing. Statistically, if the data of missing values is less than 10%, we can probably drop those values and use the data. But if it is more than 10%, Now, why is it important to, remove these missing values? Because missing values affects the conclusion or analysis that we are doing with that data set. It will not give you accurate results. Also, there will be a biasness of the data of missing values. Um, Also, there will be a biasness in the data set if there is a lot of missing values. So we should always remove the missing values available in the data set. How do we represent missing values in R? It is represented by NA or NAN symbol. Now, what are the reasons for missing values? There can be a lot of reasons that you can have missing values in the data set. Some of them can be your data it not get reasons for missing values in reasons for missing values in the data set. There can be a lot of reasons why the data. There can be a lot of reasons your data set have a lot of missing values. Some of them can be you were not able to collect data from customers or participants in a survey. Now, why can that be happening is like you created a form or you created a survey. What might have happened is the participant, you might not made all the fields mandatory to be filled and participants just skip that part. So that values becomes missing values. Or there can be a reason that your question that you asked in the survey, it is not understandable by the participants. There There can be one reason that the question is not legitimate. It might give another meaning of that question. So these are the reasons that you might get missing values in the data set. Apart from that, there can be a reason that you had that data, but due to some reason, you lost that data. Now, why should we eliminate these missing values? Missing values should be eliminated because if there are a lot of missing values, there will be biasness, and also you will not be able to perform any statistical functions on that data set, and it will affect your modeling techniques and its accuracy. Now, how to deal with missing values when you have a very large data set? So you should identify missing values first. So missing values can be in the form of NA, it can be in the form of NAN, or sometimes what happens, there can be garbage values. Now, what are garbage values? For example, you have created a field for age, and a participant, it can fill the age as 999. Though it is a number, it is acceptable, but it cannot be an appropriate age. So that becomes a garbage value. So you should always check for garbage value. It can be like 999, it can be 99. All these represents missing values. Now, once you know how many missing values you have in the data set, you should examine the cause of that missing values. So as we have earlier stated some reasons, there can be those reasons or any reason due to which you get those missing values. So you should always examine that. Then we should either drop or delete those missing values or replace it with reasonable data values. So we will learn in this session how to replace or drop these missing values from the data set. Now, how to identify missing values? There can be a lot of functions that can be used to identify missing values. Some of them are, so when you have a data set, generally you will get in R it as NA. So to count the numbers, identifying those missing values, you can use is.na. In the bracket, it can be a vector, it can be a data frame, or it can be a matrix. Now, there is also null values. So null values, we can identify these null values using is.null, Within the brackets, there will be the object or the data frame that you are using. Then there is infinite numbers. Now, what are infinite numbers? Like probably the numbers that are not divisible. Now, there can be infinite numbers. Now, there can be infinite numbers. Now, what are infinite numbers? That you don't have real values to calculate with. In most real life data sets in R, some calculations of infinite, such as dividing by 0, cannot be carried out. So we need to find out these infinite values using is.infinite. Now the next one is complete dot cases. So complete dot cases gives you or identifies all those data rows in complete dot cases. This function helps you to identify all the rows in the data set. It can be matrix or data frame that are complete, where there is no missing values. Now let's handle missing values. Now how to handle missing values? There are some functions that we can use to drop the value or find out how many missing values are there in the data set. So first is.na. Is.na, it extracts function. Let's understand how to treat missing values in R. For that, I have 4 vectors here already created. Let's see how these vectors look. So the first vector, it is a complete vector with all the values. There is no missing value in it. So it gives me the output with all the numbers. The second one, it is in the form of character. All the values are complete. The third and the fourth value vectors, they contain missing values. So you can see there is some positions, there is any value present in that vector. Now let's understand how to identify these missing values, like how many missing values are there. So like we have understand that is.na, within the brackets, we will give the vector name. So if it is v1, which is this vector, let's see what does it responds. So when you use is.na, it provides the values in the form of true or false. Wherever there will be a missing value, it will give you true, otherwise false. Let's see. If I just execute this is.na, you can see because all the values were complete, there is no missing values. The output of is.na is false in the complete positions because there is no missing value. Understand this is.na with vector 4. So if you see vector 4 here, it contains some missing values on some positions. So wherever there is a missing value, it has resulted in the form of true. Otherwise, wherever there is complete case or there is a value, the answer is false. So this is how you can identify missing values in a vector or in a data frame. Let's go ahead. Now we have understood the function omit. Now how to use omit function? Now let's convert these vectors into a data frame. So to create a data frame, I'll just give a name of variable as df equal to data.frame. Within the bracket, I'll give all the vector names here and v4. And let's execute it. Let's see how does this data frame look. So this is how our data frame looks. There are 4 columns, v1, v2, v3 and v4, and there are 6 rows in it. Now let's see different functions, how to use different functions on a data frame as well. So let's first start with na omit. What is omit? Omit means it will remove all the missing values from your data frame or vector. First, we will understand it on vector and then we will understand it on data frame. So if I say na.omit and within the bracket, I'll give the vector name. Let's say v3. and I'll execute this line. If you see, it has given me all those values which are complete in that data set. Now, how do we know that? Let's print V3 as well. So if you see 10, 20 and 50 are the complete values, it has responded me that. Then it has given me all those positions wherever there was a missing value. So on the second position, fifth position and the sixth position, it contains NA. So it is giving me the positions of those values. And the last is the attribute. It is a class. The function that we have used is the omit function. So this is how you can use na.omit for a vector. Now let's understand it on data frame. So we have created the data frame as df. If I print that, this is the data frame that we are using. Now I will say na.omit df and I'll run it. So what does it gives me is, from all the values, the complete row, wherever the row where there is no missing value, it has returned that row to us. These 5 rows, it contains missing values. So it has omitted all these rows and only have resulted in the first row as an answer of this na.omit. So this is how you can use na.omit in your data set. Next is na exclude. So how to use na exclude? Let's use it on vector as well as data frame. So first let's use it on vector. So I'll just write vector here, using it on vector. Now, na.exclude, and inside the bracket let's give v3. Okay. Before executing this, let's see what is v3 actually. So v3, there are 6 values, 3 of them are complete, 3 NAs. So if I say na exclude v3, what does it gives me? It's that all those complete values, then position of the missing values, and the function that we have used, that is exclude. Similarly, you can use it for data frame also. So na.exclude, and inside the bracket we will give the name of data frame. It will again give me the result as only the complete row where there is no missing value. Now next function that we have understood was na-fail. Na-fail, what does it do? It gives us error if there is even one missing value in vector or data frame or dataset that you are using. So let's try it on both. So na.fail, let's use it on vector 1. So if you see, there is no change in the data set. Let's print v1 as well. So it's the same. Now it has executed and resulted with unchanged data set because there is no missing value. If there was any missing value, let's try to use it on v3. So it says missing values in object and gives us an error. So it is used to find out if there is any error in the data set that we are using. You can even use it on data frame. So there was missing values in the data set or the data frame that we used. So it gave me an error. Now any pass, it do not make any change. It does not take any action for the data set. Let's say na.pass, and I'll provide the data frame that we are using. So if you see, it has given me the as it is data frame that we have used. There is no change that has happened. Now let's understand how to remove NaN values. Now NaN is not a number, not a number. So I have created a vector here where there are some NaN values. NaN using 0 by 0, 0 by 0. So there will be not a number. Let's see how to identify first these NaN. So I'll say is dot NaN, and I'll provide this variable. So wherever there will be a NaN, if you see there is this NaN, so it has resulted true there. It has given the Boolean value or the true value wherever there is NaN. Now how to remove it? So what we can do is we can save this in a data in a variable, and then it's very easy. You can just say either use na omit, na dot omit, na dot exclude, or you can do is, so we'll say G using square bracket notation with the exclamation mark. So exclamation mark is used to remove all the values that are saved in this variable. Let's see. So both of these values have been removed, and it gives us the result of the complete cases. Now, let's understand how to locate missing values. Let's see. So we can use which function. Inside which function, I'll say is.na, and I can provide here the vector that we want to use. Let's say v1. So there was no missing values in the v1, so it has resulted in integer 0 because there is no position of missing value. Let's try it again. Is.na for vector 3, let's say. So on the position number 2nd, 5th and 6th, there is a missing value. Let's just validate it. Let's print v3, and you can just validate that in the 2nd position, 5th and 6th position, there is a missing value. Similarly, you can use it on any vector, whichever you want. Now, how do we know how many missing values are there if there is a large data frame? So let's use small data frame for now and understand how to count those numbers of missing values. So for that, I am using sum function. Sum function, it will help us to count the number of missing values. Now, how will it count? We will use is.na with it, and what we will do is all the true values as a result. As you know, is.na results in Boolean values, that is true or false. So wherever there will be true, it will be counted as 1 and false as 0. So let's say is.na v3. If I run it, you can see there are 3 missing values. So it says false, true, false. So there are 3 false, 3 true. So the answer, if I sum it, let's say I'll say is.na v3. So it will give me a count of 3 because there are 3. There are 3 trues here. So it has counted it, summed it to 3. Let's say for the 4th also, let's check it for that also, na v4. So this is how you can count the number of NAs in any vector. How do we count the NAs in a data frame? So you can go it column wise or you can do it row wise. So let's understand first column wise. So column wise, I'll say, so the function is call sums, and inside the bracket I will say is.na_df. df is the data frame that we are using. So if you check it, let's print df as well. Let's see vector number 3. So there are 1, 2 and 3 NA values. So it has resulted in a total of column number 3 as 3 missing values. And same for fourth column, there are 4 missing values. So it has summed it to 4. Similarly, you can use it for row. So you can use row sums. And within the bracket, you can say is.na and df. So there are 6 rows, there are 6 values. In first row, there is no NA. Second row, there are 2 NAs, and similar for each of the rows. So this is how you can use all the functions to identify and drop the missing values and add up also. Treating missing values in R. So treating missing values is very important, as we have already discussed. It affects the output or the final result of the analysis that we are doing for the data set. So let's understand how to treat these missing values. So first we will understand how to remove any values. So first we will have a vector. Let's suppose there is a vector with name as x. It contains values wherein there are two NA values present in it. Now, first thing we will understand how to identify all the missing values. For that, we are saving it in a variable d, and the function we will use to identify these missing values is .na. And within the brackets, I have provided this vector name, that is x. So once you will execute this is.na, what we will do, it will save all the any values wherever, like the third position and the fourth and the fifth position in this d variable. What we will get as an output of this value is, we have used the square bracket notations along with exclamation sign, which means it will remove all those values present in this variable d from this vector x, and it will give you the output where all there are values that are complete cases available to us. Next is how to remove NaN. NaN means not a number. So similar ways, what is a first we should understand what is NaN. So NaN means that is not a number wherein we are dividing a number with zero, or it cannot be a proper number that can be identified. That is also considered as missing value in the data set. So let's consider that there is a vector created inside x variable. So there is 1, 2, then there is third position as NA, fourth is an NaN. Now 0 divided by 0, it can be like, it is not a number. So that is why it will be considered as NaN. So what we are learning in this, we will understand how to remove all these NaN values. Next, we will create a variable in which we will save all these NaN. So is.nan will help us to remove all these values from this data set. Similar way, the way we excluded all the values present of the NAs present in this variable, similar way we have saved all the NaN in this D variable, and then we have ignored or excluded with it using exclamation mark from this vector. Now, when you execute it, it will give you a result wherein there will be NA, because we have just removed the NaN value. That is the numbers that are not available, which are not a proper number. Now, NaN value, they are considered as NA. They are considered as missing values, but it cannot be reversed. Next is complete cases. Now, what are complete cases? It means all those rows where all the data is available. There is a vector which contains NA value as well as NaN values. Now, complete dot cases is the function. We will provide this vector. We will provide this vector inside this function. What it will result in, all the complete cases. In this, the complete case is 1, 2, and 4 value. So let's see what is the output. So it will return you the Boolean values. Now what are Boolean values? That is true and false. So wherever there is complete case, like first position, second position, and the last position, they are the complete cases where there is no NA or NaN. It will give a true value there, and wherever there is NA or NaN, it will give the false value. Next is finding the location of NaN or NA values and using sums, like what all functions we can use with this NA function. So first is which function. So which helps us to understand where all this is.na is present. It means inside this which function we will be using is.na. What will happen? All those position wherever is.na, wherever na is present, It will return us the position of that value. Next, we can use sum function, we can use column sum function, we can use row sum functions using is.na inside it. Let's understand it using R. So let's go to R and understand how to use all these functions in the, so we can use all these functions in R. So let's go to R and understand how to use it with the data set. So let's understand how to treat missing values in R. So I have created 4 vectors here. So the first vector, it is a complete vector. There are some more ways to treat missing values in R. So one of them is removing those missing values. Now to remove missing values, like when we are using any arithmetic functions, say mean, median, max, minimum, summing. So what we can use along with that is na.rm and make it true. Now na.rm means removing all the na values present in that data set that you are using. So we'll learn how to use na.rm. Then we have already understood how to use omit and exclude function to remove na values. The second way we can treat missing values is by filling or imputing the na values with a reasonable value. Now, what is filling those na numbers are actually, you can fill it with a fixed number. Let's say there are some numbers missing values in the age group, or let's say in some input related to a fixed numbers. So you can just impute those numbers, all those na values, you can fill them with a fixed number, let's say 50. So we learn how to replace all those NAs with a fixed number. Then we will learn how to impute reasonable number. Now, reasonable number here, reasonable value, we can say, like for example, we have marks of students. Some of them, they might have missed the exam, their values become missed. So what we will do, we can give them average marks or we can give them minimum marks. So we will understand how to impute those mean values or minimum values in those missing numbers. So let's go to R and understand how to treat these missing values. Let's start with understanding how to remove NA values using na.rm. So I am again using the same vectors that we have created earlier. Let's execute and create them. So in our vector 3, if I print it, you will see there are 3 missing numbers or NA values present in this vector. Now let's suppose I want to calculate mean of this value. So I'll say mean of V3. So it will provide me an output as NA because there are NA values present in this vector. If there is even one NA, even one missing value, it will respond, it will not calculate your mean value and will respond in NA. Wherein if I use V1 vector, which has all the complete numbers, and I calculate mean, in this case, my mean will be calculated easily. Now, if I want to calculate mean for this vector 3, what I will do is, I'll say, so if we want to calculate mean value for vector containing missing values, we will say mean, we'll open the bracket and I'll provide the name of the vector that I want to use mean for. Then I'll put a comma and I'll say na.rm equal to true, equal to true. And I'll execute it, and if you see, it has given me for all the numbers that are complete. No, like what is the mean value have, how this mean value have been created? 10, 20 and 50 and calculated its mean. Let's see if it is correct or not. So 10, if I say 10 plus 20 plus 50 divided by 3. So the answer is same. So it will remove all the NA values and it will for remaining complete numbers. So So this is how you can remove. You can use it for any arithmetic function you want. Let's say I want to sum up the V4 vector. So I'll say V4, I'll say NA dot RM equal to true, and I'll run it. And you can perform this function. You can use na.rm with any of the arithmetic mean you want. Let's say I want to sum v3 vector. I say na.rm equal to true. So it will remove all the all the na values and will provide me some of the remaining numbers. So it will add up 50 plus 20 plus 10, which will give me 80 as the answer. Now the next way we have understood was by data filling or data imputation. So first let's understand data filling. So when I say data filling, what I am doing is I am filling all the NA numbers, all the missing values with a fixed number. Let's create a vector 4 in which I have given 1 to 10 as the first 10 numbers. Then I'm repeating NA 5 times, and then there will be again numbers from 20 to 25. Let's see the output of this vector. So if you can see here on the let's understand how to identify the NA numbers. So you will say is dot NA, then you can say vector 4. So it will give you all those numbers, all the values as true where there is NA. To sum up this, so you can say sum. So it will give you the count of total NA values in the vector. So you can see there are 5 NA values. Now what I want to do is I want to fill all these NA with a, let's say, a specific number, a fixed number, let's say 50. So how can we do this? So what we will do, we will use our subsetting function, square bracket notation. So we will say first will be the vector name. So it is v4. In this vector, wherever, so I'll start with a square bracket. I'll say wherever there is NA values. So I'll use is.na to identify all the NA values in the vector v4, and I will put an equal to after it, and I will say a fixed number, let's say 50, and I'll enter. So what it will do is all those values, all these numbers where there is NA, it will be replaced with 50. Let's see if it happened or not. So I'll print V4 again, and you can see we have changed all the numbers with 50 here. So this is how you can replace or you can fill the NA numbers with a fixed number. Now let's understand how to impute or you can replace a number with a reasonable value. Let's say we want to impute all NA numbers, NA values with the mean of that vector. So let's take an example of V3 again, where there is 10, 50, sorry, 10, then there is NA value, then 20, 50, and NA. So what we will do actually, we will say same way, the way we used square bracket notations here, same way we will be replacing all the numbers with the mean value of this vector. So first let's print mean of this vector. So I'll say mean. I'll say vector name. So my vector name is V3. I'll say na dot rm equal to true. And I'll execute it. So my mean is 26.667. So my all any numbers, all these when I impute it. So how to do this? I'll say V3. I'll open square bracket notations and again identify all the NA values. So you will say is dot NA V3. Wherever there is NA value in this vector, put equal to, and you just equate these two things here. So So you will say mean, calculate mean of this vector by removing all the any values. So it will let's print v3 again, and if you see it, it will change all the any values with the mean number. Similarly, want to show it with another number, let's see. Let's use another arithmetic function instead of mean. Let's try to change all the numbers. Let's impute with it with minimum number. So I'll say is dot na vector 3 equal to min. So min is the function for minimum. I'll say v3 na dot rm equal to true. And let's execute it and print the vector v3. So you will see you can see the values they remain same because we didn't change the vector again. We have already imputed values. That's why there was no any, so it didn't work. So what we will do first, let's again print this vector. Now let's calculate minimum of it. So you can see the minimum value is 10. Now we will replace the minimum value of this vector with all the NAs. So I'll say v3 is dot NA, wherever the NA value is in this vector, it will be replaced with minimum NA values. Let's see. So minimum value of that vector. Now let's understand how to find missing values in a data frame and how to replace those values, those NA values, with a reasonable number. So for that, I am using a package which is called as Vim. So I'll say library VIM. So if you don't have this package, you will have to install it first. Go to package, install, or you can give the command as install.packages. Within the bracket, you will give the package name, that is Vim. Now I have already installed this package, so I'll just load it using library function. Now the next thing I'll do is there is a data set present in this package which is called as sleep. So actually I want to use this data set sleep. So I'll say data and the package name, the data set name is sleep. I'll just execute it. Let's check what is this sleep data set is. So I'll just question mark sleep and it will provide you help here in the help section. So I want this mammal sleep data which is present in the package Vim. I'll just click on it. So it is a data set which contains 62 observations for 10 variables. Now, what are these variables? It contains body weight, brain weight, non-dreamers, dreamers, what is the timing of their dream sleep, like what is the span of their life, what is their gestation period. All these variables are taken and to analyze the sleep patterns of mammal. Let's see first 6 rows of this sleep data. So I'll say head sleep and I'll execute it. So this is the data. This is how it looks. You can see there are some NA values present in it and there are a lot more in this data. So how do we check how many NAs or what is the actual summary of this data? We can say summary and you will give the name of the data set. So you can see, so there are 4 NA values present in this sleep data, in this sleep column. So it is giving you all column wise summary of this data set. So in the body weight of mammal, you will see there is minimum this much weight, maximum weight, median, and the first quartile and third quartile. Then there is brain weight. Now, when we go to non-dreaming column, you will see there are 4 NA values present in it. Similarly, for dream as well, there are some NA values present. So it will give you the counts depending upon each column, how many missing numbers are there. So we want to replace it. Otherwise, when you analyze this data, what will happen? It will not give you accurate results. So let's understand how we can do it in a data set, like in a data frame. Now let's say first we want to check all those rows where all the rows are complete. So there is a function called as complete cases, and you will give the name of data set. It will help you to get all the complete rows. So wherever there is a complete row, you can see the second row is complete. So total there are 62 rows, out of which the second is true. So wherever it is written as true, it says that those rows are complete. There are no any values. Wherever there is false, it will give you, it will tell you that there is a missing number. Now, how do we get the number of this? How do we get the number of these complete cases? For that, what we will do is, so we can use some complete cases, and in the bracket you will give the dataset name, and I'll execute this command. So there are 42 rows that are complete without any missing values. And if you want to sum up all those rows where there is a missing value, you will say sum. Then you will give an exclamation mark complete dot cases, and within the bracket you can say sleep. So you will see there are 20 rows which contains any values. Now this is for the rows. If you want to calculate it row wise, column wise, what you can do is you can say call sum sleep. So you can see these columns are complete, which are giving you the values, but there are these five columns, which contains any value in it. Let's see how many NAs are present in this columns. So you can do call sums. Then in the bracket, you will say is dot NA sleep. So you see, there is no NA value present in these first two columns. Then there are 14 NA numbers in this non-dream. Then in dream, there is 12 NA numbers, 4 in sleep, 4 in span, and 4 in gestation period. Now what we want to do is let's start with, let's say dream. We want to replace all these 12 NA numbers with the mean value of this column. So how can we do that? So we have already understood how to impute any arithmetic value inside these NA values. So we will say, let's print dream column. So we will try to, let's make a copy of this data set. Let's say df equal to sleep. Now I will be using df to do all my changes in this data set. So let's print df the dream column. So df bracket. So we want to print the dream column. So we will say df. I'll use square bracket notation, and because it's a column, so I'll use it after the comma. I'll say dream, and I'll print it. So we have to give apostrophes. Yeah. So all these values present here, you can see there are a lot of missing values present in this data. Now we will replace all these values with the mean of this column. So how do we do that? df. Let's first calculate the mean of this column. So mean, then inside the bracket, I will use the column for which I want to calculate mean. So my column is df. I'll say df $dream to be particular which column I am using. Then I'll remove all the NA values. So NA.rm equal to true. Let's execute it. So the mean value of this column is 1.972. So I want to impute this value in all these NA values present in this column. So df square bracket notation, and I'll say dream. So it is in the column and all the positions that we want to replace it in. So is.na. So is.na, and inside the bracket you will give the column name. So df $dream.
And because it's a column, so I'll specify which column it is. Inside quotes, I'll say dream equal to, so we will equate this mean value in this all in the NA value. So I'll say mean df dollar dream comma NA dot RM equal to true. I'll execute it. Let's print this column df dollar dream. So if you see all the NA values, they have been imputed with the mean value of that column. Similarly, you can do it for all the columns. Let's print the head, let's say summary of this DF. So you will see there were earlier 12 numbers of NA values present in Dream. Now there is no NA value present in this column. Now let's understand some more packages that we can use so that we can replace all the NA values at now the package that I am using for imputing reasonable numbers to our data set instead of NA values, it is impute TS. So this package, if you don't have it, you will have to install it using package, either going to package or using install.package command and load it using library function. Now, how to replace all those values that are NA in this data? So we have already copied the sleep data into a new variable called as df. It contains all the values present in sleep. It's a copy, but it is already containing. Let's do one thing. Now let's make another copy of the sleep data set, and then we will try to remove all the NA values. So df equal to sleep. Now it contains NA values in it. So how to calculate it? Call sums. Then I will give the df is dot NA df and close the bracket. So you will see there are 14 NA values in non-dreamers, then 12 in dreams, 4 in sleep span and gestation period. Now we want to replace all these NA values at once using this package impute TS. How to do that is, there is a, let's say we want to replace all these using mean. Now there are some functions that you can use in this library. Let's go through it. So what we can do is, let's create a different data frame. Let's say df1 equal to, now there is a function in this library called as na underscore mean. Now what it will do, it will remove all the NAs, calculate the mean. Inside the bracket, I'll provide the name of the dataset that I am using. So the dataset that I am using here is df. I'll put a comma, and the next thing I have to provide is an option. Option is what value you want to impute in these NA values. Now it can be mean, it can be median. Let's say we want to do it using mean, and I'll press enter. Now let's see this dataset df1. Now how to calculate? Let's directly see the column sum of this df1 dataset. So using is.na df1, and I'll close the brackets and I'll execute this. So you will see all the values have been imputed with that column, mean of that column. Like, let's see how, let's print head df1. So you will see there is 1.972, which was earlier. If you remember, we have also imputed the same in the dream column as well. So this is how you can check, you can impute all the NA values at once using this package impute TS. Now in not only mean, there are some other options that you can use here. So how can we do that? You can just do question mark NA underscore mean, and if you will execute this, it will provide you help here. So in this option, there is
You can use mean values, you can use median values, you can use mode, you can use harmonic mean, you can use geometric mean. So instead of this mean, you can just give median values. Let's try to do that as well. So df2, let's create another data frame and I'll say na underscore mean. So data set that I'm using again is df, and the option now I am using is median. And I'll press enter and let's print column sum header df2. Let's see. So you will see it has been changed to the median value. This is how you can use this package. Now let's go to another package that we can use. It is called as gtool. So I'll just put a hash. I'll say gtool package. Now let's load this library. So you will say library. If you don't have this package, you will have to install it. And the name of the package is gtools. Now there is a option here. There is a function which is called as na.replace, which we will be using to replace all the na values present in a column of this data set. So the data set that I'm using is df head df to check the first 6 rows of this data set. So there are na values present here. Now what we will do, let's calculate again the column wise sum of NAs. So is dot NA df. So you will see the number of missing values here. Now what we will do, we will use NA dot replace. So I'll say NA. Let's say we want to replace this values in the dream column. So NA dot replace. Then I'll open the bracket. I will provide the data frame name along with the column name. So I'll say dream, then I'll put a comma. Then you have to give the next thing is the function that you want to perform. What value you want to impute. Let's say I want to impute mean value. Then I'll say na.rm equal to true. So it will remove all the na values, will calculate the mean and replace all those nas with that mean value. Let's see. So if you check, all those na values have been replaced in this column. Similarly, we can use other arithmetic functions as well. Let's say na.replace df dollar. And let's say another column which contains 4 missing values. So I want to replace those values with the minimum number of that column. So I'll say na.rm equal to true. So it will replace all those na values wherever present with the minimum number of that column. So it is 2.1. So if you want to check what is the minimum value of that column, you will just have to say minimum df dollar on d. Then you will say na.rm equal to 2. So it's 2.1. So all those values NA values have been replaced with 2.1 in this column. Similarly, we can use it for any functions or even for a fixed number. Let's say na.replace df dollar dream. And I want to replace all the values with 50. So it will replace all the NA values with 50 at all those positions. So I hope you will be able to replace your NA numbers in your data set easily.